Question number 4 says that the length of 40 leaves of a plant are measured correct to 1 millimeter and the obtained data is represented in the following table. We have to draw a histogram to represent the given data. Hint is we have to first make the class intervals continuous. As can be seen in this table that the class intervals are not continuous because the upper limit of a class and the lower limit of the succeeding class is not same. Then, is there any other suitable graphical representation for the same data apart from histogram? And is it correct to conclude that the maximum number of leaves are 153 millimeter long? And why? We start solving this problem by first making the class intervals continuous. To make the classes continuous, we will have to find the difference between the upper limit of a class and the lower limit of the succeeding class. So we take this as our first class, for which the upper limit is 126, and this is our succeeding class for which the lower limit is 127. So let's find the difference. Lower limit minus upper limit, which is 127 minus 126. We get the difference as 1. We then add half of this difference to each of the upper limits and subtract the same from each of the lower limits. So half of 1 is 0.5. That means 0.5 is added to each of the upper limits and is subtracted from each of the lower limits. The new table that we get by doing this is like this. So now in here we can see that the classes have become continuous because the upper limit of a class and the lower limit of the succeeding class is same, and that is the case for each of the classes. Now our next part is to draw the histogram for this given table. So the histogram will look like this. So in this histogram we can see that we have represented the length of leaves on the x-axis and the number of leaves on the y-axis. The scale on y-axis is 1 unit represents 2 leaves, and that is because the least number of leaves that we had were 2 and the maximum number of leaves that we had were 12. Also we can see that we have made a kink or a break on the x-axis because the axis does not start from 0, instead it starts from 117.5. So the kink represents the missing class intervals. We have then drawn rectangular bars of equal widths, and the lengths of each of the bars is according to the frequencies associated with each class. So this is the histogram that is used to represent the data that we had. Now, apart from histogram, the suitable representation can be a frequency polygon, and to do that we join the midpoints of each of the rectangular bars. So the midpoint for the first rectangular bar is B, and then we have C, D, E, F, G, and H. They're all joined by the dotted lines as shown in the graph. To make the graph look like a polygon, we assume that there is a class before the class interval 117.5 to 126.5 whose frequency is 0, and the midpoint of that class is A. Also, similarly, we have assumed that there is a class after the class interval 171.5 to 180.5 with 0 frequency whose midpoint is I. Now, all the midpoints that we have in the graph are joined by the dotted lines, and this is the frequency polygon. Now, we can observe that the maximum number of leaves have their lengths between 144.5 to 153.5 millimeters in length. So we can conclude that the maximum number of leaves do not have their length as 153 millimeters as was asked in the question, and this is how we solve this question.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.